Are out again due to the inclement weather, but I have my lesson for you all prepared at home. So I have worksheets that I'm going to give out to you all, hopefully when we have class again on Thursday. But if not, I will send this to you all by email. Don't print a copy off. I will have a copy for you all, but this is just so you'll have access to it at home. The first question that we have on the board is about nuclear equations, and it deals with radiation in different forms, from alpha, beta, and positrons. Those are the three main types of radioactive equations that we will do. The first problem that you see on the screen says, write a nuclear equation for the following. U-238 decays by alpha emission. Now, one of the things you have to remember from my previous video is that when you are solving for a problem that says the word decays at the very beginning of the sentence, decays means to solve for the right side. Now, since we're going to solve for the right side, I've already drawn a box in so that we have to fill in that information. The easiest thing that you can do for this particular problem is to subtract the two top numbers. So, for instance, I have 238 on the left, I have 4 on the right at the top. If you recall from your basic math class or like a checking account, whatever you have in the bank equals the number of transactions you should have outside the bank. So if I have $238, for instance, inside the bank, that means that the transactions that I have on the right side should equate to that. So what I'm going to do is subtract 238 minus 4. 238 minus 4 gives me 234. Now, I'm going to do the same thing for the bottom number. I have 92 on the left, but I have 2 on the right. When I subtract 92 from 2, I get 90. And then I will need to look at my periodic table to identify what number 90 represents. And number 90 on my periodic table, atomic number 90 that is thorium. So that's going to be TH. Okay, TH. So that is my equation for U-238 decaying by alpha emissions. Now, if you don't quite get this, let's do a couple more examples. And always remember, you can go back and rewind. Here's the next example. You have aluminum 28 decays by alpha emission. Now, in this particular case, you have 28 on the top, 13 on the bottom for aluminum. Remember, you have to rewrite the equation in the atomic notation format, okay? Now, once I write 28 on top, 13 on the bottom, and the aluminum symbol, I'm going to draw a yield sign. That yield sign is kind of like an equal sign. Then I have beta emission. In your PowerPoint slides, beta emission is represented by 0, -1, and that little e. If you don't know what that is, you can always go back and look at your PowerPoint slides for that particular unit where it'll have the symbols and notations for the decay. Now, again, I'm going to do like I did before. I'm going to show you that the top number is 28 on the left-hand side. The arrow is going to be drawn out with an equal sign just so you can see how we're figuring this out. My X is what I'm looking for in the box plus 0 that's at the top. So I know that when I subtract 0 from both sides, of course, you know, like your old basic math classes, 28 equals X. That's going to go on the very top. An easier way to do it is, again, to say 28 plus 0. Now, for the bottom number, I have a negative sign. So with that negative sign, I am going to simply subtract. Okay? Now, I need to kind of remind you of two things, though. When we're doing these kinds of problems, you're going to have to do the opposite of the symbol once you bring that negative sign to the opposite side. So that means that when I'm solving for the bottom number, I am going to have 13 equals some number minus 1. Now remember, the signs are going to change once I bring it over to the other side. I cross this out, and my X is going to equal to 14. So that 14 is going to go on the very bottom. Now, again, to identify what this element is, to give it a name, I look for atomic number 14 on my periodic table. And on my periodic table, atomic 14 is Si for silicon. And that is my equation for alpha 28 decaying by beta emission. What it becomes is 2814 silicon. I've got another example. Let's take a look at the next one. I have oxygen 15 decays by positron emissions. Again, I have 15, 8, 0. Not 0. O for oxygen. Oops. And it yields something plus positrons. Positron is 0 plus 1 and a little e. Again, to solve this problem, I'm going to go to the top and say 15 and some number equals a plus 0. So of course I'm going to put 15 on the top. Okay. And for the bottom, remember, because I have this plus 1 on the right side, when I bring it over here to the left side, I'm going to subtract. So when I say 8 equals some number plus 1, I'm going to subtract 1 from both sides, and that's going to give me 7 equals to the x. So the 7 goes on the bottom. Now, to identify this element, I look at my periodic table for atomic number 7, and that is nitrogen. So nitrogen is the missing component. So that's 15, 7, nitrogen. I know that 15 looks kind of, odd, but that's what it is. Now, let's take a look at some more examples when we're doing an equation in which they ask you for the nuclide, when the nuclide decays by a certain type of radiation. Look at this particular one. This says identify X and write a nuclear equation. Nuclide X decays by alpha emission to give 218 Ra. Of course, Ra stands for radium on your periodic table. Now, whenever you see an equation that says nuclide, that means you're going to solve for the left side. Now, if you recall from the previous video, when we were doing problems in which you had an element already decaying by a certain radioactive material, you were solving for the right side. In this particular example, you are solving for the left side. So when it says nuclide, they want you to identify it. That means you're going to solve for the left side. So let's get started with our first example. In this problem, we have some nuclide that decays by alpha emission to give 217 radon. Now, because I know that I'm looking for the nuclide, which is the left side, I am going to leave that as a block right there, or your unknown box. And then on this side, this is really easy. All you're going to do is add the two top numbers. You don't have to worry about bringing something over to the other side, adding on the other side, or subtracting on the other side. Instead, you're going to do the operation for what you see. So in other words, if I'm looking for my X for the top number, I'm just going to say 217 plus 4 for the top number. So 217 plus 4 is going to give me 221. I'm going to write that at the very top over here, 221. And for the bottom number, same thing. I've got 86 plus 2. That's going to give me 88. And I'm going to look at my periodic table for atomic number 88. And atomic number 88 is radium, Ra. And that is my nuclide that I was solving for. So I have 221 on the top. And if you want to check to make sure that you did it right, 217 plus 4 should equal 221. 86 plus 2 should equal 88. Atomic number 88 is radium. Can't get any easier than that. Let's do another problem. This one says nuclide X decays by beta emission to give 40 calcium. Again, as you know, the 40 is on the top, and you have to figure out what that missing component is for the bottom for the atomic number. Now, again, since we are looking for calcium having decayed with beta emission, we need to know what it was originally. So I'm going to do like we did before. 40 plus 0 is 40. But on the bottom, I have 20 minus 1 to give me 19. 19, atomic number 19 is K, potassium. And by the way, you get potassium from bananas. That's just a little side chemistry note. Here's the last problem. Nuclide X decays by positron emission to give 73 bromine. Again, you're looking for the nuclide here in this missing box. And what you're going to do is draw your arrow and set it up this way. You're going to say 73 over 35 Br plus 0 plus 1E. Now, where did I get this from? From my PowerPoint slides. There, again, is a PowerPoint slide that will show you what positron emissions equal, what the notation is. This is the notation for positrons. Now, again, I'm going to do like I did before. 73 plus 0 gives me 73 on top. 35 plus 1 gives me 36 on the bottom. Then I'm going to go to my periodic table, look up atomic number 36, and that's Kr, krypton. Like kryptonite, but krypton. Kind of like what Superman had. All right. You should have enough information to help you on a couple of those problems that you will have for homework in Mastering Chemistry. The next video I'm going to show you guys deals with half-life. So let's get prepared for half-life.